2024 Methods Exam 2. I heard it wasn't so bad, so we'll see how we go. So the asymptote of this graph, well, we've got one vertical one at t, x is -1, and that's it. This function has that derivative if we want to find the original at x is equal to 2. So we can use a definite integral. So if we use the initial x at the bottom, the final x at the top, which we want it to be at 2, and then x cubed minus x dx, we also need to add the initial y, which is 5. So that will be 7. For this question, we've got this and we want to find this probability. We need to find k first, so that's 5, 10, 15, k is equal to 1, k is 1 on 15. This here is the intersection on the top, and it's going to be between 2 and 3 over the denominator would be that, which is greater than or equal to 2. So 2 to 3, that's 8 on 15, and greater than or equal to 2, that's 10 on 15. These go, and that's 4/5. So C. So for this question, what's going on? We've got this definite integral and this definite integral, and we want to know from b to c of 2 times that, so that's 2 times b to c. Now b to c is the same as b to a plus a to c, and b to a is just negative that, plus a to c is that, so 8 times 2 is 16. So the range of the composite function, so we need to make sure that the range of the inside, which is whatever, is a subset or equal to the domain of the outside. The domain of the outsides are, so it doesn't matter what the range of the inside is, because no matter what it is, it will be a subset or equal to the domain of R. So that means the domain of F is the domain of the whole thing, and we want to know the range of this for that domain. So if we go to the calculator, what we can do is we can do f max and f min. So f min of e to the power of negative x squared minus 4x, comma x, and we also need to make sure we put that domain of 1 to infinity. So x is greater than 1. I'll put greater than or equal to just because the calculator doesn't like when we don't include it. So it will happen that x is equal to infinity, and if x is infinity, it's e to the power of negative infinity, which goes to 0. So 0 will be the lower bound, and then for the maximum, we can just enter that, but change that to max. And that happens at x is equal to 2. Now at x is equal to 2, it's e to the power of 4. So it'll be 0 to e to the power of 4, and it's included because the graph is including x is equal to 2 for that e to the power of 4. Alright. Consider the function there with that domain. We want to know the inverse. So for the inverse, what we can do is I'll define f of x as the function, which is 2x plus 1. Oops. 2x plus 1 over 3 minus x. And then I'll do a solve for x is equal to f of y, comma y. And so we get this. Now that only looks like option A, but the domain of x is the same as the domain of the original, but we've got this. X is an element of real not including 2. So we can expand this to make it look a bit different. So if you just do an expand for that, you'll get option B. A fair 6-sided die is repeatedly rolled. What is the minimum number of rolls required so that the probability of rolling a 6 at least once is greater than 0.95? So we've got a binomial distribution. We don't know the number of trials, and the probability of rolling a 6, that's 1/6. And we want to know the probability that x is greater than or equal to 1 to be greater than 0.95. So we can do an inverse binom n. So if you go to menu 5, I think it's C, or D, inverse binom n, and the cumulative probability, well, greater than or equal to 1, so we want to know the left probability, which is 0.05, probability of success is 1/6, and the successes, well, that would be x is 0, so we know that x is equal to 0 should be 0.05, so that gives 17. So we've got some values for two functions, and the graph of h of x is equal to the difference must have an x-intercept, so the difference would be 4 minus 4 is 0, and that would happen at x is equal to 2. For this one, 45% of the students travel to the event in limousine, 55% were by parent. Of the students who traveled in a hired limousine, 30% had a professional photo taken, 60% had a professional. Okay, so we want to know a given probability. So let's just draw a tree diagram. They either took a limousine or they didn't, and they either took a photo or they didn't. Now, limousine, that was 45%, so 0.45. And then the ones that took a photo that hired the limousine is 0.3. And then 0.55 didn't take a limousine, and 60% had their photo taken. So if what do we want? We want the probability given that they had a professional photo, so given P, the probability that they took a limousine. So that would be limousine and photo, which is 0.45 times 0.3 over just P, which would be this plus this. So we can do a fraction and do 0.45 times 0.3. I'll just copy that. Oops. Put it on the bottom. Plus the other one, which is 0.55 times 0.6. And that works out to be 9 on 31. Suppose that this function and its derivative are defined and continuous on their domains. If which one of these statements must be true? Okay, well we had an argument about this for exam 1. The derivative should technically not include the endpoints, but that's okay. So we know we've got at 2 and at 4, we've got a negative at 2, a positive at 4, and it kind of stops here and it stops here at 5. So f is strictly decreasing on 0 to 2. Well, we don't know what's happening from 0 to 2 apart from at 2 and at 4, so that doesn't have to be true. We could have like something here. F does not have an inverse function. Well, it has to come and turn around, and then it won't be 1 to 1 anymore. So it does have, it can't have an inverse function. And we'll just check the others. We don't know if it's positive or negative. This same thing could happen here. And f has a local minimum. It doesn't necessarily have to be in the middle. 12 students in a classroom with 7 students in the first row and the other 5 students in the second row. 3 students are chosen randomly from the class. The probability that exactly 2 of the 3 students chosen are in the first row. So we've got another binomial here. They're either in the first or the second. So first row is binomially distributed. Now the number of trials, well, we're choosing 3 students, and we want to know about them being in the first row or not. So that would be 7 out of the total of 12. The probability that exactly 2, that would be 3 choose 2 times 7 on 12 squared times 5 on 12 to the power of 1. So that would be NCR 3, 2 times 7 on 12 squared times 5 on 12, and that's 2451576. Which one represents the graph of the transformed graph? What we can do is we can just take a point like 2, 1 and see what happens to that. So the 1 won't change because we've only done stuff like a horizontal translation, which affects x, and a dilation from the y, which also affects x. But we can see that x changed to 2x plus 1, so x minus 1 became is equal to 2x dash, and x dash is x minus 1 over 2. So if we take that x coordinate 2, it will become 2 minus 1 over 2, or 1/2. So this point, the minimum, should be at 1/2. That's not right. That's 1/2. None of the other options have 1/2. Okay. The function that is mapped to the function g with the following transformations, whatever, the function has a local minimum at the point with the coordinates. So we need to find the original minimum. So what I'll do is I'll just say solve the derivative. So it's x over 2 plus 2 over x, and that needs to be equal to 0. So there's two values. Just sketch the graph. To see which one's which. So the minimum's up here at positive 2. So what's the value at 2? It will be 1 plus 2. Oh, sorry, no. Yeah, 1 plus 2. 2 over 2. 1 plus 1, which is 2. So it'll be 2, 2, the coordinates of the minimum. And we dilate by a factor of 3 from the y-axis. That means it's 6, 2. And then we move it down 1, which will become 6, 1. The value of k, so we want to know this probability, but we need to find k first. So the total probability is 1, so we can do a solve. Solve the integral from -3 to 0 of x over 6 plus k dx plus the, I'll just copy this, paste it again and change everything. So 0 to 1 of negative x over 2 plus k is equal to 1, comma k. So k is a half, and then we want to know the probability that x is less than 0.5. Well, if you do less than 0.5, you're going to need to use the two integrals. But if you do 1 minus probability that x is greater than 0.5, you only have to use that. So we can do 1 minus the integral from 0.5 to 1 of the second. So 1 minus that integral from 0.5 to 1. Sorry, and I need to put k as a half. So that's 15 on 16. Okay, points of inflection. So we can differentiate, solve the double derivative is equal to 0. So derivative of 2 minus tan of pi times x minus 1/4 is equal to 0, comma x. So we've got 4n minus 3 over 4, which is the same as n minus 3/4, which is, looks like option D. Just check the y coordinate. So you can just take the first value, like n is 0 or something, plug in -3/4 into here, see what you get. So x is equal to -3/4. So the y value is actually 2, so it's not going to be this option. It's going to be one of B and A. Now 4n minus 3 is actually the same as 4n plus 1, because this is 1 away from every multiple of 4, and plus 1 is also 1 away from every interval of 4, right? So yeah, it should be A. So they've given us a value of f and its derivative, and they want us to find the gradient of the tangent to that. So this is f of x to the power of 1/2. So the derivative would be 1/2 f of x to the power of -1/2, and we also need to multiply by f dash. So now we can just plug in 4, so that would be f dash of 4, which is 15, times 1/2, times 1 on square root of f of 4. So 1 on square root of 25 is 5, and that will be 3 over 2. Okay, so we've got this algorithm and that prints those roots. I mean, what's it doing? So it's basically solving for the x-intercept. And I'm assuming all of these are the x-intercepts. So what do? We start off by defining c as f of 0, which is 18. And then if c is less than 0, we would define c as negative c. And then while c is greater than 0, if f of c is equal to 0, then we print c. Yeah, well, that's if it's the y-intercept, it'll give it back to us. Sorry, the x-intercept. And if this is the x-intercept, it'll give it back to us. And then at the end, we just define it as the next value down. So what will happen is we'll go from 18 all the way down until our first value, which looks like 3. And then what happens is we'll go down from 3 and subtract 1 and get 2. And then we'll get the last value of negative 3. So that looks like option C. Yeah, so we'll keep subtracting all the way down. We won't have anything, and it's all positive, so we don't do this. Yeah, so we'll get to 3. 3 is definitely the first one. And then it looks like 2 is the next value. So we would just subtract. And then f of 2 will be 0. So we'll print that. And then we'll define it as 1. Then go down all the way to the negative. So I'm pretty sure this is C. Find the value of x which maximizes this area. So the area of this trapezium is 1/2 times a plus b, which is 3x plus x, or 4x, times the height. Now the height is the square root of 100 minus x squared. So we can solve the derivative of that is equal to 0. Solve derivative square root 100 minus x squared over 2 times 4x is equal to 0 comma x, and that's 5 root 2. Does it say the area? It says the value of x. Consider the normal random variable that satisfies that. So we don't know the mean. It's normally distributed with a mean. Standard deviation we don't know, but we've got 2 values to solve for them. So we've got z1 is equal to 10 minus the mean over the standard deviation, and z2 is 18 minus the mean over the standard deviation. So what we can do is we can basically just figure out these standard normal values and then solve simultaneously. So if you do a menu 5 for probability distributions and then normal, we'll do inverse normal, and then the area is going to be 0.2 for the 10 value, and then the other area is 0.2 and it's greater than 18, so I'm assuming it's just going to be positive, but the other one you'll just put 0.8 here. Yeah, okay, so now we can do simultaneous equations, and we do m and s for mean and standard deviation, and then for the first one it's this value is equal to 10 minus m over s. For the second one, that would be 18 with the positive. So that's the mean and the standard deviation. We want to know the probability that x is less than 12. So that'll be menu 552, negative infinity to 12. I'll just enter and then I'll just change these values. So 14 for the mean, well, that's actually for here. And then this for the standard deviation. So that's 0.337. All right, last question. The function that has an average value over that interval and satisfies that property for all x is nominal of real, the value of the definite integral 2 to 6 is. So what's that? The average value, that's 1 over 2 times the integral from 0 to 2 of f of x is equal to k, and then that means that's equal to 2k. Now we want to know that integral, but x plus 2 is the exact same. So that means the integral from 2 to 4 is also the same. So, and 4 to 6. So that's what this is. And if we add 2 to the top and bottom values, you'll get the exact same. So this will be 2k and this will be 2k. So the sum will be 4k. Alright? So that wasn't so bad. Consider this function. State in terms of a where required the values of x for which f of x is equal to 0. So x is equal to -1, -a, 2, and 2a. Find the values of a for which the graph of y is equal to f of x has exactly 3 x-intercepts. So if they have 3 x-intercepts, we definitely have these two, so we just want one more. And these two brackets will either be the same, and that will be if a is 0, or this can be equal to, a can be equal to 1, for this to be the same as that one. But if a is 1, then this will be the same as that, but this will also be the same as that. So we can't have a as 1, because that will mean we only have 2 x-intercepts. But the next one is that a can be -2, and if a is -2, so if a is -2, then this will be the same as that, and then that would be x plus 4, which is fine. So that's 3. And then now we look at this being either one of these. So -2a is equal to 1. So a is -1/2. And check that that works. So that will be fine because that's different. And then for this one, x minus 2a being equal to 2, so that's again a is equal to 1. And that doesn't work. So our values for exactly 3 x-intercepts are a is equal to 0, a is equal to -1/2, and a is equal to -2. So exactly 4 would just be everything else. So, but be also careful that 1 has, when a is 1, that's 2 values, not 4. So you also exclude the 1. So it will be -2, -1/2, 0, and 1. Alright. That's a bit of a tricky question for the start. Okay. Let g be the function there. Find g dash x. Okay, so let's start by defining. Oops. So I'll just define g of x as x plus 1 squared times x minus 2 squared. So they've kind of given you a clue here that this a is equal to 1. If you wrote it down here for 3, it actually only has 2 x-intercepts, so you can't have that. And also it's another clue for the 4, because that's not going to give you 4 as well. But anyway, here we've defined it and we want to find g dash x. So the derivative of g of x is this. So g dash x is equal to 2x minus 2, x plus 1, 2x minus 1. Yeah, so this a is 1, that's a clue. Find the coordinates of the local maximum of g. So for the maximum, we just solve that's equal to 0. You get these 3 values. Now, for these three values, we need to figure out which one's the maximum. So I'll just sketch this graph here. And you can see the middle one is the maximum. So 1/2 and then g of 1/2, which is 81 on 16. Okay. Find the values of x for which g dash x is greater than 0. So surely we can just solve that. Okay, so that would be for -1 to 1/2 union 2 to infinity. Okay, consider the two tangent lines to the graph of y is equal to g of x at the points where x is that and x is that. Determine the coordinates of the point of intersection of these two tangent lines. So I think for working out it's enough to just say the first tangent line is equal to the second. So you can just say tangent line or menu calculus tangent line, and then it's g of x, comma that point, which was -√3 plus 1 over 2, and that gives that. So you can write 3√3 x minus 3 times 2 √3 minus 9 over 4 is equal to, and then the other point was +√3 plus 1. So equal to 3 times 2 √3 plus 9 over 4 minus 3 √3x. And if we solve for the intersection points, comma x, that gives x is 1/2, and if you plug that in here, you get 27 on 4. Okay. Let g remain as the function, where is 1. Let h be a different one, where is -1. Using translations only, describe a sequence of transformations for h for which its image would have a local maximum as the same coordinates of that of g. So the coordinates of the maximum was 1/2 81 on 16. And then this one here we need to find the maximum of that. So for the maximum, we can just solve the derivative. Oh, sorry, I haven't even defined it. So I'll just define h of x as x plus 1. So it's x plus 1, x minus 1, which is x minus 1 whole squared, times, and then it's x plus 2, x minus 2, which is x minus 2 whole squared. So menu 3.1, solve the derivative of h is equal to 0. And we get these three values, so 1, 3 over 2, and 2. And it's so a, the only thing that's changed is a, and a is a translation. So the middle one's still going to be the maximum because the translation doesn't change which one it is. And then h of 3 over 2 is 1 on 16. I have to find it wrong. So h, it should be x minus 4 squared because it's x plus 2, x minus 2 squared. Did I do that right? I'm just gonna define it properly. Okay. Oh. That's weird. What did I don't even know what I did wrong. That's okay. So I'll delete all of these. Okay, so these are the proper values. 0 and the middle one is, as I said before, the middle one is still going to be the maximum. So what's h of 0? H of 0 is 4. So the maximum of this one is 0, 4. Now we want to change the 0, 4 to 1/2 81 and 16. We just need to translate both. So translate 1/2 units right, and then for this one it's going to be translate 81 on 16 minus 4. So what's that? It's 17 on 16. So translate 17 on 16 units up. Using a dilation and translations, describe a different sequence of transformations of H for which its image would have both local minimums at the same coordinates as that of G. So now we need to find the minimums actually of both. So of G of X, which, where's that? So it'll be G of -1 and G of 2. Okay, so the minimums of G are -1, 0 and 2, 0. And the other one is the minimums of H, which were these weird values. So H of -√10 on 2, which is -9 on 4. And then this would just be the √10 on 2, and then the -9 on 4 as well. So we want to make these both the same. So first of all, we can just move it up 9 on 4, that's fine. But we'll figure out the x. So a dilation from the y-axis would change the x. Now, if I change this to -1, I don't think that's going to change to 2. I think that would just change the positive one. So that's wrong. But you will see that both of these are symmetrical about a point. So what's the middle of -1 and 2? It's -1 plus 2 is 1/2, right? And the middle of these is 0, right? The -10, those two. And so what we can do is we can change these values and then move them 1/2 units. So what would that value that we need to change it be? So if I √10, if I do √10, what will that change it to? √10 will be like 1 on √10. That will change to -1/2, and this will change to a +1/2. Now I want to change this to -1 and this to 2. So I need to, if I move that left 1/2, that's going to be -1, but that's going to be 0. So I should do it a point after, because this one's kind of like a bit pushed to the left. So I should do, maybe I'll try this one first. No, I should do a point that's after and then move it left 1 on 2. So this one I can make it, what value if I add -3/2 and then I add 1 on 2, that will be -2/2 or -1. And this one here, if I make that 1 on 2 and I add 1, no. If that's 3/2 and I add 1/2, that would be 2. So it seems like I need to change it to 3/2. So that would be by multiplying by 3 on √10, which is quite weird. That's pretty hard. So dilate by a factor of 3 on root 10 from y. So just to check, that would turn this into negative 3 on 2, and that would change this to positive 3 on 2. And then what do I need to do? I need to add 1/2, so translate 1/2 units right. That would mean that this goes to negative 2 over 2, which is negative 1, and this one will go to 4 over 2, which is 2, which is actually, that's good. And then this negative 9 over 4, we'll just need to move it up. So translate 9 over 4 units up. That's pretty hard. That is pretty hard. Okay. That's it for that question. That was pretty long for question 1. How many marks is that? 12. Okay. Express the derivative as a hybrid function. So here we've got this common theme of the derivative with the endpoints. But just be very careful. This time it actually matters, because if the gradient is the same at that point, then remember we can't differentiate a sharp point. But if they're joined smoothly, which they do join, so 1/3 here is 12 plus 10, and that's 22. So they do join, but do they join smoothly? Well, the gradient is always 30 here, and the gradient is 0 here. So they don't join smoothly, so you can't ever include the 1/3. And then this is an endpoint. So it would be f dash t is equal to the hybrid function. The derivative of this is 12, and that's from 0 not included to 1/3 not included. And for the 22, that's 0, and just t is greater than 1/3. And that's because these don't join smoothly, so we can't differentiate that point. Okay. Find the average rate of change in temperature predicted by the model between t is 0 and t is 1/2. So 1/2 is kind of in both. So I'm just going to define the hybrid function. So f of t, define as hybrid. We've got two equations, and then the first one was 12 plus 30t for 0 less than or equal to t, which is less than or equal to 1/3, and then it was just 22 for t is greater than 1/3. And so we want the average rate of change, so that would be f of 1/2 minus f of 0 over 1/2, and that's 20. Okay. Another model for the temperature can be given by that. Find the derivative. So this goes, and this would be positive 60 e to the negative 6t. And that's just because multiply that, you get 60, and copy and paste the rest. Find the value of t for which g dash t is equal to 10. Give your answer to correct to 3 decimal places. So menu 60 e to the power of negative 6t is equal to 10, comma t. So that's ln 3 decimal places. 0.299. Yeah. Find the time t is an element of 0 to 1 where the temperatures predicted by the models f and g are equal. Give your answer correct to 2 decimal places. So this would just be, so I probably should define g of t, which is the 22 minus 10 e to the negative 6t. And then we want to know when is f of t equal to g of t between 0 and 1. And it's to 2 decimal places, comma t. So that's 0, which isn't included, and that's 0.266. Find the time when the difference between the temperatures predicted by the two models is the greatest. Okay. So the difference between the two, between 0 and 1. So we're only looking at the, actually we're looking at the whole thing. Never mind. So what you can do is you can maybe just sketch both. So we've got f, you have to do it in terms of x on the CAS, and g of x. Now it's not showing because it's probably, okay, so this is g, that's the exponential, and where's f? Okay, I'm just going to do, so my x min, I'm just going to do -1 up until +1 because we only want from 0 to 1. And then for my y minimum, I might just honestly make it like -5 to 5. Where's f? I think it didn't even draw it for us. Whatever. Let me just do menu 3, 1. I'm just going to sketch both of them separately. So the first one was 12 plus 30t, and that's for 0 to 1/3. 12 plus 30x. And then the other one, still can't see it. Oh, it's up here. Alright, and then the difference is up there. So we want to know when's the difference the biggest between the two. And it looks like that's over here. Right? So that's at that 1/3. And at 1/3 we're on, so it's just going to be g of 1/3 minus f of 1/3. Oh wait, it wants the time and it says to 2 decimal places. I don't think if it was that value that they would ask for 2 decimal places. Okay, what I'm just going to do is just, well, that's obviously the value here, the biggest difference. Let's just solve the derivative of f of t minus g of t is equal to 0, t, and only from 0 to 1/3. That's 0 to 1. And that's the value. So is 0.11 really the value? Oh, well, 1/3 is 0.3. So 0.1 is about here. It's probably like, I don't know, whatever, that's the answer. Let me just check the value. Okay, so that's the difference. What about f of 1/3 minus g of 1/3? Yeah, this one's bigger. Okay, so 0.11, 0.12. Okay. The amount of power in kilowatts used by the heater T hours after it's switched on can be modeled by the continuous function P, whose graph is shown below. The amount of energy used by the heater in kilowatt hours can be estimated by evaluating the area between the graph of y is P of T and the T axis. Given that P of T is continuous for T is greater than or equal to 0, show that A is equal to 1.2 e to the power of 4. So 1.5, these should join. 1.5 is equal to 0.3 plus A e to the power of negative 10 times 0.4, which is equal to 0.3 plus A e to the power of negative 4. So 1.2 is equal to A e to the negative 4. A is equal to 1.2 over e to the power of negative 4, or 1.2 e to the power of 4. Find how long it takes after the heater is switched on until the heater has used 0.5 kilowatt hours of energy. So T hours after it's switched on. So find how long it takes until it's used 0.5 kilowatt hours. So the amount of kilowatt hours. So find when P of T is 0.5. So they like hybrid functions a lot. This exam, P of T, whoops. P of T defined as this, which is 1.5 from 0. Okay, so it's definitely not going to be the 1.5. I'm just going to solve when is the second part. 0.3 plus 1.2 e to the power of 4, which is A, times by e to the power of negative 10t. When is that equal to 0.5 comma t? And that happens at, just says give your answer in hours, so they want it exact. So that, alright. Oh, I made a mistake. So here, the amount used, so this is just the amount of power. So that's the amount of power, and this is the amount of energy. The area is the amount of energy, and we want when it's used 0.5 kilowatts of energy. So we probably should define it and say the integral from 0 up until a certain time of P of T dt, that's equal to 0.5. Okay, so P of T, I'm going to define it. That's 1.5 from 0 less than or equal to T less than less than or equal to 0.4. And then here, that was the 0, it's just this. 0.3 plus 1/2 e to the power of 4. Oh, sorry, 1.2 e to the power of 4, e to the power of negative 10t. And that's from, for t is greater than 0.4. And we want to solve when the integral from 0 to t of P of T dt is equal to 0.5 comma t. Okay, so it didn't work when you do exact, but that's 1/3. Alright, find how long it takes after the heater is switched on. So it says give your answer in hours, so just, you don't need to write anything. Find how long it takes after the heater is switched on until the heater has used 1 kilowatt of energy. Did they just ask the same question, but just different? It's a bit dumb. Maybe it says so that you can lose 3 marks instead of 1, which is a bit annoying. Okay, so that's just the integral from 0 up until t. I shouldn't use t here because t is the variable. Um, 1 kilowatt hour. Okay. I'm just trying to figure out why they would ask the same question twice. Okay, well it's just 1.33. Whatever. That's pretty weird. One second. Alright. Next question. The points shown on the chart below represent monthly online sales in Australia. The variable Y represents sales in millions of dollars. The variable T represents the month when the sales were made, where T is 1 corresponds to January 2021. T is 2 corresponds to February 2021, and so on. A cubic polynomial P can be used to model the monthly online sales. The graph of y is equal to P of T is shown as a dashed curve on the set of axes below. It has a local minimum at 2,500 and a local maximum at 11,400. Find the values of A, B, C, and D. So the first equation is that P of 2 is equal to 2,500, but also P dash of 2 is equal to 0. And then P of 11 is equal to 4,400, and P dash of 11 is equal to 0 as well. So let's just define P of T as A times T cubed plus B times T squared plus C times T plus D. Alright. And then we just want to also maybe define dP of T as the derivative. Alright. Okay. So that's the derivative, and now we can solve menu 371. We want to solve for, we have 4 equations, and A, comma B, comma C, comma D. So P of 2 is equal to 2,500. dP of 2 is equal to 0. P of 11 is equal to 4,400, and dP of 11 is equal to 0. Now, those are the values. So A is 5.7, so how many decimal places? 2 decimal places. 5.76. B is negative 112.35. C is 380.25. And D is 2142.80. Alright, let Q be that function. Okay, this is getting a bit annoying. where Q of t is equal to P of t minus H plus K. They love transformations, both of these exams. Obtained by translating P, which can be used to model monthly online sales in 2022. Find the values of H and K such that the graph of y is equal to Q of t has a local maximum at 23,4750. So the local maximum was initially at 11,4400, and that's now become 23,4750. So I don't know why they're just asking the same questions over and over again. Alright, so the translation, so H is a horizontal translation to the right, and that's exactly what we want it to be. So that would be 12, and K is a vertical translation up, and that would be 350. Okay. Another function, a new one, can be used to model the monthly online sales. Part of the graph is shown below. Complete the graph from 24 to 36. Label the endpoint t is equal to 36 with its coordinates. Alright, so going to need to define f of t as what it is, 3000 plus 30t plus 700 cos of pi t on 6 plus 400 cos of pi times t on 3. Okay, now from here we want to finish the graph off, so if I just get rid of everything else here, and now f of x should stay, but we'll put a domain, and the domain is, we'll just show the whole thing from 0 to 36. All right. Now, the window that we want to use, we'll make it the exact same as what we've been given, so on the grid. So we'll make the window, the x values are going from 0 to 36, but I'll just go -2 to 38, so just 2 above and below. The y minimum, that's going from 0 to 6,000, so I'll go -1,000 to 7,000. And then this scale, we can go up by 2s, and this scale we can go up by 500s, which is what the grid looks like. So that's the image of what we want to draw. And if you want the point 36, well, you can just do f of 36, which is 5,180. So that's this point. Oh, no, that's not 36, that's 24. Oops. F of 24, that's 4,820. We didn't need that anyway. And for this graph, you can basically, it just keeps doing the same thing over and over again. We've just got to figure out the minimums and maximums. So it's a bit annoying, but that's okay. So we've got up to basically around here. We'll just get that one. Oops. Oh, I'm doing a minimum. Whoops. Okay, the minimum is here. And then maximum. And then this maximum. Okay, let's just sketch those for now so that we can get rid of these so that the numbers aren't so bad. So the maximum was 24.04748. So it's about the same, 24 and 4820. We can just go down basically from here, up and down till 27.78. So 27.78 is about here. And that has a value, so all these points are just pissing you off in your way. Let's get 27, and the y value is 3282 or 3281.5. So 3,200 will be about here. and it's about here. Okay, so that's your first minimum. And then you go up to 30, at 30 you go up to 3601. So at 30 you go up to 3601, which is 3601, which is about here. So you've got this, then that's actually the maximum. So I'll just draw it a little bit higher because my drawing's a little bit off. And then you go down again to oh wait, I've done maximum, so let me just get that one, the end point. Let me just get rid of this, not that, oh, that's okay. And then we want this minimum. Which is 32 and 34 and 9. So 32 and 34 would be just a bit below here. Oh, I think I've drawn this part. It should be 36, that's up here. Okay, and then 3409 would be down here. And then we basically just go up to our maximum at 36, which we said 36 was 5180. So up here, all right? So we've got this. That is really annoying. All right, and all these points there just confuse you even more. It's okay. That's that. The function f predicts that every 12 months monthly online sales increase by $N million. Find the value of n. Every 12 months monthly online sales increase by $N million. So if we say like from here, f of 0 and then f of 12. So we can just do f of 12 minus f of 0, and you can say $360 million. Okay, find the derivative. So we'll just do shift minus t f of t, and the derivative is negative 400 pi sine pi t over 3 minus 350 pi sine pi t over 6 over 3 plus 30. Okay. Hence, find the maximum instantaneous rate of change for the function f correct to the nearest $1 million per month, and the value of t in the interval 0 to 36 when this maximum rate occurs. So remember, you're doing the maximum rate, you need the double derivative of this. So f double dash, or they say hence, so what you should probably write derivative of f dash of t is equal to 0. And then if we solve menu 3.1, derivative of this is equal to 0, comma t, and we say t is between 0 and 36. You will get these values here. Value of t when this maximum rate occurs. The values of t. So I think these are all the same. But let's see. So now we just want to do this, but t is equal to this. And then what about the next value? Okay, so actually no. Now, so we don't have the 1, so get rid of that. And then we do the next value. So that's not it as well. And then this one here. Okay, so that's even bigger, so we can now get rid of this one. And see this. So not that one. Okay, so what's the overall period? The overall period of this is going to be 12? Yeah, the intersection of the 2. The overall period is 12, and so every 12 this is going to repeat. So you'll have 10, but then the next one up will probably be 22.2. That does it. So this one, and then 34.2. Okay, and it's to 1 decimal place. So its maximum is 725.4. So it's the nearest $1 million per month, so that's 725. But the values of t is 10.2, 22.2, and 34.2. So I think that's a way that you save time for this question, because so many values. Okay, so I finished that rubbish question. At an airport, luggage is weighed before it is checked in. The mass of each piece of luggage in kilograms is modeled by that continuous random variable. Write a definite integral which gives the probability that a piece of luggage is labeled as heavy. It's heavy if its mass exceeds 23. That will be the integral from 23 to 30 of f of x dx. Find the mean of x. So that's just... Okay, so I'm going to define a new f of x, which is 1 on 67500 times x squared times 30 minus x. Okay, and now the mean is the integral from 0 to 30 of x times f of x. And that's 18. Now, find the standard deviation. So that's the square root. So here, the working out. Square root of the integral from 0 to 30 of x minus the mean squared, so 18 squared times f of x. Now what's that? So square root of the integral from 0 to 30 of x minus 18 squared times f of x dx, and that's 6. Given that that the mass of a piece of luggage is more than the mean, so probability that given that x is more than 23, find the probability that it is labeled as heavy. Oh, more than the mean. Sorry, more than 18. And then find the probability that it's labeled as heavy, so given greater than 23. And so that's the probability that, we'll just write integral straight away. That's the integral from, the intersection is 23 up to 30 of f of x over the integral, so from 18 to 30 of f of x dx, and to 3 decimal places. So so the top of the fraction is just going to be the 23 to 30. As we said, we already worked that out in the first question. Oh, no, we didn't work it out, so we need to put that. So that's going to be 23 to 30 of f of x dx, and the denominator is 18 to 30 of f of x dx, and that's 0.446 to 3 decimal places. Alright, use the following information to answer parts C and D. Of the travellers flying from the airport, 10% do not check in any luggage, 40% check in exactly 1 piece of luggage, 50% check in exactly 2 pieces of luggage. Assume that the mass of each piece of luggage is independent of the number of pieces checked in by each traveller. Okay. Use the value of 0.234 for the probability that a piece of luggage is labelled as heavy. Let W be the discrete random variable that represents the number of pieces of luggage labelled as heavy checked in by each traveller. Show that probability that W is equal to 2 is 0.027. So the number of pieces of luggage labelled as heavy checked in by each traveller. So that would be, so 50% check in 2 pieces of luggage. And then that would be 0.234 for the probability squared, and that's 0.027. Let's just double check so we see if we've done it right. 0.5 times 0.234 squared, and that works out to be 0.027. Cool. It says correct to 3 decimal places, so I'll just write 0.27378, which rounds to 0.027. Alright, complete the table, correct to 3 decimal places. So for 1, that would be 0.4 times 234 to the power of 1. Um, 0.4 times 0.234. Is that right? Okay, well, let's just check if it adds up to 1 then. And then for the first one, well, 0.1 times... No, I'm doing something wrong. So we've got probability that W is equal to 1. So for here, we just did 0.5, exactly 2 pieces of luggage, times 0.234 squared. The number of pieces of luggage labelled as heavy checked in by each traveller. Ah, okay, and then the rest need to be not heavy, because in this one... okay, so for this one... okay, so that could be actually... It could be 0.5 times 0.234 to the power of 1, meaning that one would be heavy, and then the other one is not. Also to the power of 1. No, sorry, 1 minus 0.234. And then also, if they do this one, that would be 0.4 times the 0.234 to the power of 1, and that's the only one that's going to be labeled as heavy. And then if they don't check in any luggage, then none of them are labeled as heavy, so that doesn't count. So it should be this plus this to the power of 1 times 1 minus 0.234. Hopefully that's right. Okay, and then we can check for 0. That means that we've got 0.4, and it's going to be 1 minus 0.234 for both of them. And then, no, that's for one piece of luggage. It's just going to be the 1. And then for the 2 pieces of luggage, one of them, sorry, we want none of them there. So that's going to be the other one squared. And then you can also plus 0.1, because for those that don't check in any luggage, they don't have any that are labeled as heavy. And let's see if these add up to 1. So that plus 0.027. No, so I'm missing something. So for the people that check in this piece of luggage, that's one piece of luggage, and that's times 0.234 to the power of 1. So that one has to be heavy. Or you can have people that check in two pieces of luggage, and one of them's heavy and one of them's not heavy. And then for those that don't check in any pieces of luggage, then they can't have any that's heavy. So that should be right. Okay, I'm pretty sure the 0 is right, because for 0 you've got the 2. I think I'm just missing the something for the middle one. So what else can happen? What have I done wrong? Um, 0.5. Sorry. There's two ways that this one, because either the first can be heavy or the second. So that should fix it up. So that's 0.273, and let's see if these add up to 1. So that plus the 0.027, and that's 1. Okay. On a particular day, a random sample of 35 pieces of luggage was selected at the airport. Let p hat be the random variable that represents the proportion of luggage labeled as heavy in a random sample of 35. let p hat be the random variable is heavy. Okay, so we want p hat is greater than 0.2, which is the same as probability that x over 35 is greater than 0.2, or that's the same as the probability that x is greater than 7, or x is greater than or equal to 8. Right? And what's our binomial distribution? So x is binomially distributed. The number of trials is 35, and the probability of success is a random sample of 35 was selected at the airport. Proportion of luggage labeled as heavy. Oh, so the heavy is 0.234. Right? Yeah. Okay, so here we can do menu 55B, and we have 35 trials, probability of success 0.234, lower bound is 8 and upper bound is 35, and that works out to be 0.595 to 3 decimal places. Determine the probability that p hat lies within 1 standard deviation of its mean. Correct to 3 decimal places. Do not use a normal approximation. So the mean of this is just the probability that x is less than or equal to the mean is so it's going to be 1 standard deviation of its mean. So the mean is 35 times 0.234, and then 1 standard deviation would be square root of 35 times 0.234, 1 minus 0.234, and then 30. Oh, this is going to be a bit ugly. And then this is 35 times 0.234. That's plus, sorry, on the right hand side, and the left is minus square root 35 times 0.234, 1 minus 0.234. Okay, now that works out to be what? So if we do, I'm just going to do this. Now we want it to be the number of trials is 35, probability of success is 0.234. The lower bound is 35 times 0.234 minus square root of this, the 35 times 0.234 times 1 minus 0.234. And then I'm just going to copy and paste that. And then the upper bound, paste it and put a plus there. Now that works out to be 0.684. In one random sample of 50 pieces of luggage, 10 are labeled as heavy. Use this sample to find an approximate 90% confidence interval for P, population proportion of luggage labeled as heavy. So we can use the menu, statistics, confidence intervals, 1 prop Z interval. So we found that in a selected random sample of 50, 10 were labeled as heavy, so 10 successes out of 50, and we want a 90% confidence interval. So correct to 3 decimal places, it would be 0.107 up until 0.293. A second random sample of 50 pieces of luggage is selected using this sample, the approximate 95% confidence interval for P. Okay, so the population proportion of the luggage labeled as heavy is wider than the one obtained in part EI. State the minimum and maximum number of possible pieces of luggage labeled as heavy in the second sample. Well, if it's wider, then that means what? So remember that our formula is P hat minus z times the square root of p hat 1 minus p hat over n, and p hat plus z times the square root of p hat 1 minus p hat over n. Now, if we want our thing to be wider, we want this to be smaller and this to be bigger, or this to be bigger and this to be small, both of them to be bigger, this to be bigger and this to be bigger, meaning that the minimum must be, for it to be wider, p hat just has to increase, it has to be bigger than 10. So the minimum is 11 and the max is, what's the max? Oh, it's not just 50, is it? Well, if it's 50, we don't have a confidence interval, because that would be, p hat would be 1 minus 0, 1, so it would just be 1 to 1. Oh, and also if the top, so we subtract 10 from the top, because if we have 40 are labeled as heavy, that's the same thing, right? But it's just that you'll have it skewed the other way. And so you would have to do 1 less than the 40, which is 39. That's a good question. All right, is this the last question? Yeah, okay, so almost there. The graph below shows the compositions g of f and f of g, where f of x is sine x and g of x is sine 2x. The graph of y is equal to g of f of x has a local maximum whose x value lies in the interval 0 to pi over 2. So let's just start off by defining everything. Oh, sorry, I think I wasn't even showing the screen. Yeah, I just said that this has to be bigger and this has to be bigger. So it has to increase from 10. But at 40, when that's 40, it will be the same thing. So 1 less than that is 39. Now, the graph of that, so we're going to define these two. So f of x is sine x, and g of x is sine 2x. And then we want to find the coordinates of the local maximum of g of f. So menu 3.1, shift minus g of f of x is equal to 0 comma x, and that's for 0 to pi over 2. 0 less than or equal to x less than or equal to pi over 2. And it says to 1 decimal place. What have I got on? I'm just going to do it on the graph. Okay, let's get rid of everything. Okay, so we've got g of f of x, and then we can do a zoom window settings from, I'll just say negative pi over 2 to pi over 2. And then this x scale can just be whatever, 0.001 or 0.01 or whatever. And then y minimum is going to just say negative 1 to 1 or something. And this can just be 0.1 as well. Okay, so the maximum is here. Analyze graph, maximum. And that is 0.9 and 1. State the range of g of f where x is an element of 0 to 2 pi. So 0, g of f of 0 is what? That's 0. And does it go? I should just sketch it from 0 to 2 pi. Okay, so we've got this, and it actually goes below. Oops. Alright, so the minimum is here. Now, it just looks like this just repeats itself. So the minimum is just going to be -1, and the maximum is going to be 1. So I think it'll just be -1 to 1. Alright, find the derivative of f of g, so not g of f. So, derivative of f of g, f of g of x. That's, so 2 cos 2x cos sine 2x. Show that the equation cos sine 2x is equal to 0 has no real solution. So if cos of sine 2x is equal to 0, that happens at pi over 2 and negative pi over 2. So that means sine of 2x is equal to, well, that would happen at, what's this? So 2n plus 1 pi over 2. And 2, where n is an element of integers, 2n plus 1 pi over 2, that's more than 1 or less than -1. So what you can say is, because remember that's going to be like, for example, pi over 2, that's 3.1 whatever over 2, divide that by 2, that's going to be greater than 1. So you can say 2n plus 1 pi over 2 is greater than 1 or less than -1. Therefore, and you can say, and sine only has a range of -1 to 1. Therefore, no solutions. Find the x values of the stationary points where f of g, where x is an element of 0 to 2 pi. So the x values of the stationary points. So for the x values, well, we can sketch f of g of x. Oh, that won't give us any proper values. So we can solve this is equal to 0. So I think that's why they've made us, that's actually why they've made us look at this. Because if this is not equal to 0, when we solve this is equal to 0, we're only solving 2 cos 2x is equal to 0 from 0 to 2 pi. So 2 cos 2x is equal to 0 comma x, and I'm just going to copy that but change that to 2 pi, and that's x is equal to pi over 4, 3 pi over 4, 5 pi over 4, or 7 pi over 4. Find the range of f of g where x is an element of 0 to 2 pi. Okay, so what's the range of f of g? Let's just sketch f of g. No, that looks a lot nicer. Now, what's this value? Okay, let's just see what f of g of pi over 4 is. Sine of 1. Okay, so I'm assuming it's just negative sine of 1 to positive sine of 1. Okay. Write a single definite integral that gives the area bounded by the graphs of y is equal to f of g of x and g of f of x. So these are the same, so you can just do 2 times one of them, and it will be from 0 up until pi, it looks like, of the top minus the bottom. Which one's the top? Top is g of f, bottom is f of g. So 2 times the integral from 0 to pi of g of f of x minus f of g of x dx. Hence state the area bounded by the graphs of those in the interval 0 to 2 pi, correct to 2 decimal places. So 2 times the integral from 0 to pi of g of f of x minus f of g of x dx to 2 decimal places is 4.97. Okay. Let f, so you're not including the endpoints now for 0 to 2 pi. So f stays the same, but you've just limited the domain to 0 to 2 pi instead of all real values. Find all values of x in the interval 0 to 2 pi for which the composition f1 of g of x is defined. So the range of the inside, the range of g, what's that now? G is sine 2x, so that's negative 1 to 1, right? That needs to be restricted to the domain of this, which would actually be 0 to 1. 0 is not included, 1 is included because 0 is not included here, but 2 pi is bigger than 1, so 1 is fine. Now what we need to do is we need to figure out the domain of g that gave that. So what's the domain of g that gives a range of 0 to 1? So if we have sine 2x, well, 0, so that would happen at 0, and up until, when is sine equal to 1? Pi over 2. So it would be 0 to pi over 2, right? But it's actually also, so that's for that. But remember that the graph from 0 to 2 pi, the graph's going to do that, right? So we've actually also got this part. So is it just 0 to pi? And all the values of x in the interval 0 to 2 pi for which the composition f1 of g. So the range of g is negative 1 to 1. I made a mistake. It's sine 2x. Whoops. So it's not going to look like that. It's actually going to look like that up until pi, and that up until 2 pi. So we've actually got, this is now pi over 2, and this is pi, and this is 3 pi over 2. So it's actually, x is an element of 0 not included, up until pi over 2 included, union pi not included to 3 pi over 2, which, sorry, that's 3 pi over 2 is up here. So that's pi over 4, not pi over 2. Oh no, we're going up to, oops. And that goes up to here, and then this is up to pi to 3 pi over 2, and they're both not included because that comes down. So I think that's the answer, and that's the end. So I think it was it's not bad of an exam. It's just a little bit of like annoying things for your calculator, which might slow you down. So hope everyone went well, and let me know if I've made any mistakes in the comments.